Imagine gazing at the horizon and witnessing a dawn that dominates half the sky. NASA has unveiled images of an unprecedented occurrence where a star named Betelgeuse shed a massive portion of its outer layer. This event is termed a surface mass ejection, and according to the space agency, the expulsion was 400 billion times the mass of a typical solar flare from our sun. Scientists described this phenomenon as observing stellar evolution in real time, with a star ejecting such enormous fragments of its physical structure. Surprisingly, the cataclysmic explosion of this super red giant is challenging much of what we understand about the cosmos. Why did Betelgeuse lose its outer layer, and how will this impact the universe? Let's explore. Constellations consist of numerous stars arranged based on mythology and legends. They continue to be utilized for navigation today. One such star is Betelgeuse, which ranks among the largest and most luminous stars in our night sky. The brilliant ruby-red star known as Betelgeuse is positioned in the upper right shoulder of the winter constellation Orion the Hunter. Upon close observation, astronomers identify it as a turbulent entity with a 400-day-long heartbeat characterized by regular pulsations. Due to its distinctive oranged hue, Betelgeuse is easily recognized. It serves as an excellent example for skeptics that stars do in fact exhibit different colors. Also referred to as Alpha Orionis, it is the second brightest star in the constellation after the blue supergiant Rigel. Betelgeuse is a fascinating object for star studies and observations due to its variable nature as well as its unusual name. Typically, stars with the designation Alpha are the brightest in their constellations, although Rigel, Orion's other bright star, outshines it. Betelgeuse holds the title of Alpha Orionis due to its name, brightness, size, and reddish tint. It is also among the most recognized stars. Interestingly, this star inspired both the character and the film Betelgeuse. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and it ranks as the 10th brightest star overall in the sky. Earth is relatively near to Betelgeuse. Astronomers have not yet determined its precise distance from our planet, but they estimate it to be between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star closest to Earth. In our galaxy, there are only about 200 identified red supergiant stars. The Sun has a radius that is approximately 764 times smaller than Betelgeuse. If this star were to replace our Sun in the solar system, it would extend past the asteroid belt and even beyond Jupiter, implying that Earth, Mars, Venus, and Mercury would all be completely engulfed. Betelgeuse is 16,128 times as massive as the Sun. This supergiant has 126,000 solar luminosities and is observable from 548 light-years away. The surface temperature of the star is around 3,600 Kelvin, making it cooler than the Sun. Only about 13.3% of Betelgeuse's emitted energy is visible light. If human eyes could perceive light across all wavelengths, Betelgeuse would surpass Sirius as the brightest star in the night sky. Betelgeuse loses approximately 1 solar mass every 10,000 years. The red star is enveloped by a nebula due to this material being ejected unevenly from the star in all directions. A cloud of material 250 times larger than the star surrounds Betelgeuse. The size of this nebula is also believed to be 30 astronomical units, or 30 times the distance from the Sun to Earth, which is the distance separating the Sun and Neptune, the furthest planet in the solar system. Our solar system's Sun regularly expels mass into space, a phenomenon known as solar flares. However, the Sun only releases tiny fragments of its outer atmosphere, referred to as the corona, leading to the term coronal mass ejection, CME. As a result, coronal mass ejections and surface mass ejections can occur at different times. When a star expels a portion of its unstable outer atmosphere, it results in a CME known as the corona. CMEs from our solar system occur quite frequently and can influence Earth. Earth and its inhabitants encounter CMEs that can travel over 1,800 milliseconds while releasing magnetic fields and plasma into space, occasionally allowing them to reach Earth within a few hours. A CME can disrupt and damage Earth's satellites and power systems when it occurs on the side of the Sun facing the planet, and it can sometimes endanger astronauts in orbit. The recent discovery sheds light on the extraordinary cause of Betelgeuse, originating from 2019. The material expelled by the star erupted into space, cooled, and formed a cloud of cosmic dust that obscured Betelgeuse's brightness from ground-based observers. Furthermore, Betelgeuse's previously steady pulsing pattern has been disrupted. The CME on Betelgeuse is exceptional because it released 400 billion times more mass than a standard CME, causing the star to quiver like a bowl of gelatin, according to a NASA news release. According to Andrea Dupree, an astronomer at the Center for Astrophysics, the star's internal convection cells may be in chaos, while the photosphere, what we perceive as the star's surface, struggles to reconstitute itself. Astronomers have monitored the star's constant pattern for the past 200 years, but it no longer exists. All red giants, including Betelgeuse, are dying, and being able to observe this process will provide research with valuable insights into stellar evolution. Most stars in the universe derive their energy from nuclear fusion, which eventually depletes, leading to a series of fascinating stellar transformations before the star ultimately dies. When a star is born, it consists of hydrogen, which under the force of gravity fuses together in the star's core to create helium. During the fusion process, a significant amount of heat and light energy is typically released in a nuclear explosion. This energy travels to the star's surface and is emitted as a photon into space. As the star ages, its primary fuel, hydrogen, diminishes and helium begins to fuse with carbon to create carbon. After the helium is exhausted, neon will eventually combine with carbon to produce iron. At this stage, the fusion of neon with iron absorbs energy instead of releasing it. As there is nothing to counteract the star's immense gravity, when iron starts to fuse, the star collapses in on itself, resulting in a supernova explosion. A supernova, one of nature's most potent forces, can generate more energy than 10 billion suns. Stars change color throughout their existence, transitioning from the youngest, hottest blue forms to the older, cooler red varieties depending on their stage of stellar evolution. The Greek scholar Ptolemy in 168 AD oddly depicted Betelgeuse's color as having a reddish tint. 3 centuries prior, Chinese astronomers described the star as looking yellow, potentially suggesting that Betelgeuse was once a yellow supergiant. Astronomers might acquire a deeper insight into how red stars lose mass in their final phases before detonating in a brilliant supernova from Betelgeuse's outburst. As Dupree remarks, we've never witnessed a substantial mass ejection from a star's surface before. We are facing something occurring that we don't completely grasp. It's an entirely novel phenomenon that we can observe directly and resolve surface details with Hubble. We're experiencing stellar evolution in real time. However, it remains uncertain whether this development indicates Betelgeuse's imminent supernova explosion. Given the peculiar nature of these findings, NASA warns that Betelgeuse may not have reached the end of its existence, even if it is nearing it. Cosmic time spans are extensive, and red supergiants perish quickly in comparison. NASA forecasts that Betelgeuse will explode within the next 100,000 years. Betelgeuse has been the focus of rigorous study since the 1st century BC. More recently, a researcher named Sarov Nance and her team aimed to ascertain the possible timing of supernova explosions in red supergiants like Betelgeuse to understand how such a massive star would behave over time. Nance and her colleagues conducted numerous simulations using Betelgeuse as a model and then compared their results with observational data. Why did Betelgeuse abruptly dim and fall out of sync with its usual cycle when it is unlikely to explode for another 100,000 years? Betelgeuse was ejected from its home in the Orion OB1 association, which includes the stars in Orion's belt, and has been observed traveling through the interstellar medium at a speed exceeding 4 light-years. By mid-February 2020, Betelgeuse had lost 3 times as much brightness, declining from magnitude 0.5 to magnitude 1.7 after beginning to drop sharply in October 2019. By February 17, 2020, Betelgeuse's brightness had stabilized for nearly 10 days and the star had begun to brighten once again. However, 5 days later, Betelgeuse appeared to have completely stopped its dimming, effectively concluding the dimming phase. Given that there were no significant changes in the infrared on February 24, 2020, it seemed that the recent visual fading was unrelated to the expected core collapse. Another study concluded that the star's dimming was most likely due to a cloud of large-grain circumstellar dust. Dust absorption was ruled out from having a major effect in a study that used measurements at sub-millimeter wavelengths, but the fading appears to have been caused by large star spots. Further analysis indicated a dramatic increase in Betelgeuse's brightness between February 21 and February 22, 2020, followed by a sustained and rapid brightening since February 27, 2020.